Hi and welcome to another chemistry lesson. I almost said another alcohol lesson, but yes, it is a lesson on alcohols, which is an organic compound that contains an hydroxyl group. So for example, we have propanol, would be 3 carbons with a hydroxyl group at one end, or it can be in the middle one as well, and that would be propan-2-ol. Okay, now we're looking at the properties of alcohols, but before we can really go into the properties of alcohol, I do first need to explain a special type of force that exists. Remember, when we talk about the properties of elements, we are concerned about the forces that are at work between the molecules in that compound, the properties of compounds. So we need to go and look at a special type of force that we have not looked at, and that force is got a little bit of a wrong name, but we will use it since that is what it's called, and that is called hydrogen bonds. Okay, it's a special force that exists when we are working with hydrogen bonded to a high electron negative element. Okay, so what happens when hydrogen bonds to something, to another element that has a high electron negativity? So for example, here I've got my hydrogen and it is bonding to oxygen is an example of something with a high, it's the second highest electron negativity. What happens in this case is that because, and this is specifically the hydroxyl one, because the hydrogen has, or the oxygen has a high electron negativity, it attracts, in this covalent bond, it attracts the electron very strongly towards itself, giving it a very likely a positive charge, leaving the hydrogen with its single proton and the electron more towards the electron negative element. And this obviously causes a polar molecule. A polar molecule, you'll remember, is a molecule that has a positive and a negative pole. So in this case, this is what is called a hydrogen bond. It's not about the bond between these two, but when there exist other molecules like this. So for example, we've got another molecule, okay, hydrogen molecule and an oxygen molecule. The same thing is happening to them, and in this case we have it like that. Now the positive end is attracting the negative end, and the negative end is attracting the positive end. So there's this attractive force, but this attractive force exists usually between ionic molecules, but when hydrogen bonds not in an ionic bond, okay, but rather in a covalent bond with an electron negative element, he's not giving his electron, he is sharing his electron, but because the other element is just attracting that electron so highly, it is left being more positive and the other element more negative, causing this hydrogen bond. And that's exactly the bond that exists in water, and it is a quite strong bond. Now, because of this, what we have when we have, and I'll start simple, when we have methanol, okay, if I had 2 methanol compounds, sorry, that shouldn't be carbon, okay, 2 methanol, not compounds, but molecules, okay, then this is going to happen. Okay, there is going to exist hydrogen bond attractive forces between the hydroxyl ions, because they would have definitely charges and attract one another like that. So even though the carbon, there might be an induced dipole forces between the two methane structures. They're not nearly as strong as the forces in the between the two, the hydrogen forces, or hydrogen bond forces, if I can call it that. And so that is actually where the attractive forces will happen. That is why methanol has a higher attractive forces between its molecules than methane. So if I were to have methane, okay, I've got methane. Methane is definitely a gas at room temperature, while methanol, okay, just by adding the hydroxyl, causes higher attractive forces. Methanol is a liquid. Okay, now you can smell methanol when it's nearby. That means if you can smell a liquid that's nearby, it means there are molecules escaping from the surface. So methanol definitely has a high vapor pressure, but definitely a lower vapor pressure than methane. Okay, now what happens? So basically what we're saying is that the bonds that exist in alcohols, the forces that exist is hydrogen bond forces. But when the carbon chain gets longer, okay, you remember that the forces increase. The induced dipole forces increases when the carbon chain gets longer. That is because there's now more probability that the electrons will be grouped unequally, and now all of a sudden at some point those forces will overtake the single hydroxyl forces that exist, or the hydrogen bond forces that exist. So even though this is a polar molecule, in other words, it's polar because the molecules attract each other, and this is a polar molecule. As the carbon chain gets longer, it becomes non-polar. Okay, non-polar. The effect that the hydroxyl has on the whole molecule is less. Now that has another effect, because remember, the polarity of if something is polar or non-polar makes it soluble in water or soluble in oil. Okay, methanol is soluble in water because it's polar. Water is also polar. Okay, as if I look at this is 1, 2, 3, 4, 5. Okay, that makes it pentanol. Okay, is less solvable in water. Obviously, it's not all of a sudden not soluble. It becomes less and less soluble until we can't really dissolve it into water anymore. Okay, so it becomes, on a scale, it becomes non-polar. So let's look at a very, very common example, glycerol. We've looked at glycerol. Before that is its commercial name, or its common name. Glycerol has 3 hydroxyl ions combined here. So obviously you can see this is definitely polar, because this is all 3 of them are polar. So this is a very strong polar molecule, and because of the number of carbons, there's a few carbons, not a lot, but there's a few carbons, but also there are 3 hydroxyl groups, so there is quite a bit of hydrogen bond forces acting on different glycerol. Let me write it, glycerol, think like that, can't remember. Okay, but there are quite a lot of strong forces in here. So the glycerol is it is a liquid, so it is still a liquid, but it is a very viscous liquid. In other words, it resists flow. It's a little bit sugar, almost like syrup, not as viscous as sugar, but it definitely resists flow. So it's in a sense a little bit oily. So it's in a sense a little bit thick, if I can say it like that. So again, what are we talking about when we're talking about properties? What is important to understand? It is important to be able to compare different elements with each other and relate them together. So for example, how would this one's properties relate to this one's properties? Okay. And again, if there's nothing, it's a hydrogen. Okay, how would these two relate? They've got the same number of carbons, but how would they relate with one another? And then it's important for you to be able to use your understanding of the forces that are the intermolecular forces that are at work between the molecules to explain why there would be a difference and what you would expect. So for example, because the hydrogen bond forces are stronger than the weak London forces or the induced dipole forces that are existing in here, because they are stronger, we would expect this one to have a higher boiling point, a higher viscosity, okay, a lower vapor pressure, etc. and etc. And also you should know whether something is polar or non-polar, so that you can say whether it is soluble in water or soluble in oil. Okay, so hopefully you are slowly but surely getting the point when we're talking about the properties of chemical substances, and you will see it's actually very simple, but you do need to understand what type of forces are involved and how different aspects of a molecule influence the forces at work. So thank you very much for watching. We'll see you in the next video. We'll look at some alcohol reactions. See you there.